You can drink no alcohol, look healthy, and still be building fat inside your liver. That sounds impossible because most people think fatty liver is an alcohol problem or a weight problem. It can be both. But it does not have to begin there. Sometimes it begins with repeated sugar deliveries. A sweet coffee sends one delivery in the morning. A soda at lunch adds a faster one. A cookie in the afternoon feels small, but the liver still receives it. To you, these moments feel separate. To the liver, they can look like traffic. Your liver is not just a detox filter. It is a biological warehouse. It stores energy, converts overflow, and ships fat into the blood when there is something to move. When too much sugar keeps arriving, especially as liquid sugar and added sugar, the warehouse cannot simply let it pass through. It has to process the overflow. You do not feel your liver making triglycerides or storing fat. The liver adapts quietly. So quitting sugar for 30 days is not a cleanse. It is not a magic reset. It is about changing what arrives at the loading dock. For 30 days, the trucks slow down, the shelves fill more slowly, and the fat-making machines receive less raw material. Before we go day by day, we need to understand the warehouse itself. Because the problem is not just sugar. The problem is what the liver is forced to do with it. The warehouse is already working. Most people imagine the liver as a filter where something dirty goes in and something clean comes out. That picture is partly true, but it is far too small. The liver filters, but it also builds, stores, converts, packages, and ships. Inside this warehouse, carbohydrates can become sugars, fats can be stored or shipped, proteins can be rebuilt, alcohol has to be processed quickly, and hormones or medications may need to be cleared or redirected. The liver is not asking whether something tasted sweet. It is asking what has to happen next. When sugar arrives, the answer depends on the amount, the form, the speed, and the state of the warehouse. Glucose can be used by many tissues. Your muscles, brain, and cells can burn it for energy. Fructose is different because it is handled much more heavily by the liver. That does not make fruit poison. Dose matters, form matters, and speed matters. A piece of whole fruit arrives with water, fiber, chewing resistance, and plant structure. That structure slows the delivery. A soda does not arrive that way. A juice does not arrive that way. A sweet drink is sugar without breaks. The liver does not only respond to what arrives, it responds to how fast it arrives. At first, the liver stores some incoming sugar as glycogen. Glycogen is useful short-term storage, but those shelves are limited. When the shelves are full and more sugar keeps arriving, the liver needs another route. This is where de novo lipogenesis enters the story. The term means new fat creation. The image is simple. Sugar comes in, the shelves are full, and the factory turns part of the overflow into fat. That fat can become triglycerides. Some triglycerides leave the liver in the bloodstream. Some fat can remain inside the liver itself. This is why fatty liver can be misleading as a phrase. It makes people look only at dietary fat, while the liver may also be reacting to sugar overload. A major liver review describes sugar and fructose as important mediators of non-alcoholic fatty liver disease, because high sugar intake can increase liver fat creation and impair fat oxidation. Sugar does not just enter the liver and disappear. It enters a decision system, and if the deliveries keep coming, the warehouse has to keep deciding what to do with overflow. The deliveries. Slow down in the first 3 days. Your liver is not repaired. It is relieved. A fatty liver does not disappear in one weekend, but the signal environment can change quickly. When added sugar is removed, the warehouse receives fewer fast deliveries from soda, juice, sweet coffee, candy, pastries, syrup, cereal, and late-night desserts. That sounds simple from the outside. Inside the liver, it is not small. Every one of those foods was not just a taste. It was an incoming load. Now the loading dock is less crowded. The storage shelves fill more slowly. The conversion machines receive less raw material. The shipping department gets less pressure. This is why liquid sugar matters so much. A sugary drink is not only sugar. It is sugar delivered at high speed. There is little chewing, little fullness, and almost no structure to slow the delivery. You can drink a large sugar load before the body has time to register what happened, but the liver still receives the delivery. This is also why whole fruit and fruit juice should not be treated as the same signal. Whole fruit is a biological package. Juice is the package removed. Fruit slows the delivery, while juice can send it straight to the loading dock. For most people, the main liver problem is not one apple. It is sugar without structure arriving again and again. Adult cohort data from the Framingham Heart Study found that sugar-sweetened beverage intake was associated with fatty liver disease. That does not prove that one soda causes fatty liver, but it fits the biology. Repeated liquid sugar gives the liver repeated fast deliveries, so during days 1 to 3, the change is quiet. There are simply fewer deliveries, and sometimes that is the most powerful first step. The liver can only change its output when the input begins to change. The fat-making machines get less input. Around days 4 to 7, the story moves from incoming traffic to internal production. This is the part most people never see. They think quitting sugar is about willpower. Inside the liver, it is about raw material. When less overflow arrives, one of the most important machines inside the warehouse receives less input. That machine is the pathway that can turn excess sugar into fat. The liver does not use this pathway because it is broken. It uses it because it is trying to manage surplus. When energy is needed, sugar can be burned. When storage is available, sugar can become glycogen. But when the shelves are full, part of the surplus can move into fat making. This is not a moral failure. It is logistics. In controlled adult research, fructose-sweetened beverages increased visceral fat and worsened blood lipids and insulin sensitivity compared with glucose-sweetened beverages in overweight and obese adults. That does not mean every gram of fructose is dangerous. It means the delivery pattern matters. Liquid fructose-containing sugar often arrives quickly and without much fullness. The liver becomes a major processing site for that load. When added sugar disappears for 30 days, the fat-making machine receives less raw material. The conversion pressure drops, and once the fat-making signal becomes quieter, another part of the warehouse can begin to change. The fat already inside the liver is not concrete. It is traffic. Liver fat can start moving. By the second week, the important idea is not that liver fat has vanished. The important idea is that liver fat is dynamic. It can move in the wrong direction when the metabolic input is wrong. It can also begin moving in the better direction when the input changes. Think of liver fat like inventory in a warehouse. If trucks keep arriving, inventory grows. If fewer trucks arrive, stored material can begin to be used, moved, or reduced. This is why a 30-day sugar break matters most for people who are already sending the liver a high sugar load. If someone barely eats added sugar, the change may be modest. If someone drinks soda, juice, sweet coffees, and eats sweets every day, the change can be large. Human studies in younger people with fatty liver show that reducing free sugar can improve liver fat within weeks. Those studies are not perfect adult proof, but they show that the liver can react when the sugar signal changes. For adults, the strongest picture comes from beverage studies, cohort data, and fructose mechanism research. Too much fast sugar gives the liver too much to process. Less fast sugar gives the liver room to change direction. And once the inventory starts changing, the next signal becomes easier to understand. That signal is insulin. The insulin signal can become clearer. Insulin is supposed to be the warehouse manager. When energy enters the body, insulin helps tell tissues what to do with it. In the liver, it helps control glucose output. In a healthy system, the message is clear. There's enough energy right now, so stop releasing more. But when the liver becomes crowded with fat and repeated sugar traffic, that signal can become harder to hear. The warehouse manager is still speaking, but the factory floor is too loud. This is one reason fatty liver and insulin resistance often travel together. When insulin signaling weakens, the liver may keep releasing glucose, even when the body does not need more. The system becomes louder, not calmer. Sugar is not the only cause. Sleep, movement, body fat, genetics, total calories, alcohol, medication, and stress all matter. But added sugar can be one of the clearest signals to remove. In the adult fructose beverage study, the fructose-sweetened group showed reduced insulin sensitivity compared with the glucose-sweetened group. So, between days 10 and 20, The story is not that insulin suddenly becomes perfect. The story is that one major source of noise has been lowered. Less overflow has to be converted, and the insulin message can become easier to hear. And when the insulin message becomes clearer, the shipping department may also change. The shipping department may slow down. Your liver is not only a storage room, it is a shipping center. When the liver handles fat, it can package triglycerides into particles and send them into the bloodstream. That is normal because the body needs a way to move energy. The problem begins when shipping becomes a response to overflow. More sugar arrives, more conversion happens, and more triglyceride packages may leave the loading dock. Some fat can also stay inside the liver. This is why blood triglycerides are useful in the sugar story. They are not just numbers on a lab report, they are evidence that the shipping system is active. A high liquid sugar pattern can push this system harder in susceptible people. A lower sugar pattern can reduce the raw material feeding it. The adult beverage trial is useful here because it looked at visceral fat, lipids, and insulin sensitivity. Those are warehouse markers. They show how the system handles storage, shipping, and signaling. This does not mean every person's triglycerides will drop dramatically in 30 days. It means the biological direction makes sense. When the warehouse receives less overflow, the loading dock may not need to send out as many emergency fat packages. And this brings us to the last part of the month. The liver is not cleansed, it is quieter. The liver gets less biological noise. By days 20 to 30, the most honest word is not healed. The better word is quieter. The liver has received fewer fast sugar deliveries. The fat-making machinery has had less raw material. The shipping department may have worked under less pressure. That is not a miracle. It is a different workload. And this is where the detox myth becomes unhelpful. A detox makes people imagine that the liver was dirty and needed to be scrubbed. But the liver was not asking for a scrub. It was asking for fewer things to convert. This is why the 30-day change should focus on added sugar and free sugar, not fear of all sweetness. A whole orange is not the same signal as orange soda. A bowl of berries is not the same signal as a bottle of juice. Whole fruit arrives with structure, while liquid sugar arrives like traffic with no traffic lights. For most people, the first target is not whole fruit. The first target is sugar without structure. Soda, juice, sweet coffee, candy, pastries, syrup, desserts, and sweetened cereals are the deliveries that keep the warehouse busy. Remove those for 30 days, and the liver gets something rare. It gets space at the loading dock and in the conversion system. That is the real change, not a cleanse, a reduction in biological traffic. Taken alone, these changes can sound small. No soda, no juice, no sweet coffee, no candy, and less dessert. But inside the liver, they all remove the same signal. Less fast sugar reaches the loading dock. Less raw material enters the fat-making machines. Less pressure reaches the shipping department. Less noise competes with insulin. The liver does not need a detox tea. It needs fewer emergency deliveries. So if you quit added sugar for 30 days, the question is not whether your liver becomes perfectly repaired. The better question is whether you have stopped asking it to process the same overload every day, because your liver is not just a filter, it is a warehouse, and every warehouse changes when the deliveries change. So tonight, look at one thing you drink or eat every day and ask a better question. Is this food nourishing my body, or is it another truck at the loading dock?